All right. This is the Intermediate Algebra Final Exam Review, page 8 and 9. The reason there's some why I started 31 already is because I was in the middle of making the video. Luckily, it was at the very beginning, and I got a call on my phone, so it shut the video off. I forgot to. I usually put it in airplane mode, but I forgot. Okay, so I'll just start this over. Okay, so I have, pretty sure that's gamma over beta is equal to 4m over a. Again, keep capital, capital, lowercase, lowercase. We want to solve for a. Okay, notice a is in the denominator here. What we can do that would be helpful is if we multiply both sides of the equation by the LCD to get rid of the fraction. So the LCD would be beta a, or ba. So let's multiply both sides by that. Beta a, beta a. So here, the betas cancel, and we're left with a times gamma. And over here, the a's cancel, and we're left with 4m beta. Divide both sides by gamma. They cancel. And we're left with a is equal to 4m beta over gamma. So you would type that in, and you've solved for a. Okay, you just need to isolate that a. Okay, number 32. If a number is added to the numerator of 11 over 37, and twice the numbers added to the denominator of 11 over 37, the resulting fraction is equivalent to 1/3. Find the number. The unknown number is blank. Okay, so sounds very wordy, but let's pick this word problem apart to see if we can set up an equation to solve for the number. So if a number is added to the numerator of 11 over 37, so we'll use x for the number. So a number is added to the numerator, so then that would be 11 plus x. And twice the number is added to the denominator of 11 over 37. So then we will add 2 times the number, so plus 2x. The resulting fraction is equivalent to 1/3. That means this fraction, if they're equivalent, this will equal 1/3. Find the number. All right, well, we now have an equation, so let's multiply both sides of the equation by the LCD. And the LCD, since this is factored, would be 37 plus 2x, and then times 3. Okay, so we'll multiply both sides by that. It's really the same as doing cross multiplication. So if you're familiar with cross multiplication, the result's going to be the same. So we'll end up with 3 times 11 plus x is equal to 1 times 37 plus 2x. So we could just write it like that. Okay, distribute here. 33 plus 3x is equal to 37 plus 2x. Okay, and then we will subtract 2x from both sides and subtract 33 from both sides to get x is equal to, so 37 minus 33 is 4, and we have x is equal to 4. So the unknown number is 4. Okay, so you see, don't just automatically skip word problems. Just read through them, see if you can set up an equation, and then solve it. Okay, so we want to 33, find the cube root. Okay, so the cube root, since -8 can be written as -2 cubed, the cube root of -2 cubed is -2. So a is -2. Okay. The next one, number 34, use the properties of exponents to simplify the expression Write with positive exponents. Assume that all variables represent positive real numbers. Okay, so we want to simplify this. We can use our properties of exponents when we have a quotient and we have the same base with exponential expressions. We can subtract their exponents. So 1/10 is larger than 1/20, so I'll do y to the 1/10 minus 1/20. Okay, that fraction I can't add or subtract until I have a common denominator, so multiply the numerator and denominator of 1/10 by 2/2. So y to the 2/20 minus 1/20, we have y to the 1/20. Type exponential notation. Okay, so we can keep it in exponential notation. So it would be y to the 1/20. Okay, that's all for that one. 35. Use the quotient rule to divide. Assume that all variables represent positive real numbers. Okay, so we want to use the quotient rule, which means we can combine both of these under the same square root. So x to the 9th, y to the 5th over xy. Now we can simplify the fraction. Okay, so quotient rule, you will subtract the exponents. So x to the 9 minus 1, y to the 5 minus 1. Okay, because when there's not an exponent written here in the denominator, it's assumed to be 1. So we have the square root, x to the 8th, y to the 4th, okay, which gives us the shortcut. Since this is a square root, if the 2, which is the index, goes evenly into the exponent, then just divide. So it would be 8 divided by 2, x to the 4th. 4 divided by 2, y squared. And when you do that division, it gets rid of the square root. Okay, so we have x to the 4th, y squared. Okay, so we have the next one, which is the square root of 75 minus the square root of 147. So you can only subtract when you have like radicals. So what we need to do is see if we can simplify each of these radicals individually, so that we can, combine the two. So let's see. The square root of 75, so we'll do the little scratch work over here. So the square root of 75 is equal to the square root of 25 times 3, so that is 5 square root of 3. Okay, so if 3 goes into 147, which 5 plus 7, I'm just adding 1 plus 4 is 5 plus 7 is 12. 3 goes into 12, which means 3 does go into 147. So let's see, 3 into 147. Just do some quick division. We see it's 49. So the square root of 147 is equal to the square root of 49 times 3, which is 7 square root of 3. So with this scratch work here, I can write the square root of 75 as 5 square root of 3, minus, I can write the square root of 147 as 7 square root of 3. And now we have like radicals because it's 5 square root of 3 minus 7 square root of 3. Oops. We just add the whole number part. 5 minus 7 is -2 square root of 3. Okay, the long way would be factor out the square root of 3, and then you would have 5 minus 7, which ends up being the same thing. So you can just do the shortcut by doing the whole number part. Okay, so this is equal to -2 square root of 3. And then page 9, the last page of the exam review, we want to rationalize the denominator. When you rationalize the denominator, you multiply the numerator and denominator by the conjugate of the denominator. So that would be 1 plus square root of 3. Okay, so I will leave the numerator factored for now, 8 times 1 plus square root of 3, and I will multiply out the denominator. Remember, these are conjugate pairs, so use the shortcut. 1 times 1 is 1, and then minus square root of 3 times square root of 3 is 3. Okay. And then we have 8 times 1 plus square root of 3. Again, just keep the numerator factored for now. And then 1 minus 3 is negative 2. Okay, so the reason I kept the numerator factored is because a 2 goes into 8 4 times. You don't forget about the negative that's there. So we have negative 4 times the quantity 1 plus square root of 3. Okay, there's a 1 left in the denominator, so just exclude that. And then now you can distribute the negative 4, which would be negative 4 minus 4 square root of 3. Negative 4 minus 4 square root of 3. Okay, number 38, solve. Okay, so we want to solve this radical equation. Okay, when we solve these types, let me recopy it. 8x minus 7 minus 5 is equal to 0. You want to isolate the radical part first. So let's add 5 to both sides. Square root of 8x minus 7 is equal to 5. Okay, to get rid of the radical, we will square both sides. Whenever you raise both sides to an exponent, then we always have to check the proposed solutions at the end. So 8x minus 7 is equal to 25, okay, because it's like the square and the square root cancel each other out. And we can add 7. 8x is equal to 32. And then divide both sides by 8. So you get x is equal to 4. Remember, don't forget to check. Let's check it. So we check it in the original. You can do it just in your head or you can write it down. So we take the original, 8 times 4, because that's our proposed solution, minus 7 minus 5 is equal to 0. So we have the square root of 32 minus 7 minus 5 is equal to 0. Square root of 25 minus 5 is equal to 0. 5 minus 5 is equal to 0. Checks. So the solution is x is equal to 4. Okay, 39, use the square root property to solve the equation. The equation has real number solutions. Okay, so the square root property, we want to isolate the part of the equation that is being squared. Okay, so we would add 5 to both sides. So we have x squared is equal to 5. Okay, then we take the square root of both sides. Whenever you take the square root of both sides, you need the plus or minus. Only on one side. So the square root of x squared is x, and it's equal to plus or minus the square root of 5. The square root of 5 we can't simplify, so we have x is equal to plus or minus square root of 5. Okay, and it says use a comma to separate the answers as needed. So if you can't find the plus or minus button in your My Math Lab, then you would want to do negative square root of 5, comma square root of 5 like that. So you could do the plus or minus square root of 5. That means two solutions. The one is positive and the one is negative. Okay. All right, and number 40, use the quadratic formula to solve the equation. The equation has a real number of solutions. Okay, so the quadratic formula, x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so that is the quadratic formula, and we will solve this equation using the quadratic formula. Okay, so the first thing, we need everything isolated to one side, which means we will have to subtract 3y. So we have 0 is equal to 2y squared minus 3y minus 9. And now that it's in this form, you can see that the coefficient of y squared is a, so a is equal to 2. The coefficient of y is b, so b is equal to negative 3. And the constant term is c, so c is equal to negative 9. Now we just plug these values into the quadratic formula and we'll solve. Okay, so we have negative 3 plus or minus the square root of negative 3 squared minus 4 times 2 times negative 9, and then all over 2 times 2. And now we just simplify. Okay, so a negative 3 is just a positive 3, plus or minus under the square root, negative 3 squared is 9. And then we have, this would be negative 8 times a negative 9 would be a positive 72 over 4. Okay, still working under the square root. So again, this is x equal to, we have 3 plus or minus the square root. We have 9 plus 72 is 81 over 4. Okay, so we have 3 plus or minus the square root of 81 is 9, and that's over 4. And now since we have 3 plus or minus 9 over 4, we should separate this into two separate solutions. So we have x is equal to 3 plus 9 over 4, and x is equal to 3 minus 9 over 4. That's where the plus or minus comes into play. So for the first one, 12 over 4, so we get 3. And then for the second one, 3 minus 9, that's negative 6 over 4. We can simplify that, so that would be negative 3 over 2. Okay, so y is, oh, and I wrote x, but it's, since the variable is y, all these x's should be y's. So we have y is equal to negative 3 over 2, comma 3. Okay, and that's solving using the quadratic formula. You can check those answers if you like, but as long as you use the quadratic formula correctly, there's no need to. All right, and that concludes the practice final exam for intermediate algebra.